Hello, everybody. So yeah, I can see that there's a lot of excitement here in the audience. And I have a feeling that that excitement is because we're about to talk about regulations. So how many people here deal with regulations directly? Oh, wow, a fair amount of you. So I hope with this talk that, that for the people who don't deal with regulations, that I'm going to convince you to be excited to continue not dealing with regulations. And then for those of you who do deal with regulations, that I'm going to convince you to be excited because I think maybe the most exciting thing about regulations is the prospect of not having to think about them so much. And so that's really what this talk is about, and obviously it's about that and open source. But so the question is, how would you think less about regulations? And one way to think less about regulations is to not have to worry about implementing them so much. And then the next question is, well, how can you not worry about implementing them? And the answer to that is Open Reg Tech. And so Open Reg Tech is a FINOS special interest group. And one of their focuses is how can we deliver regulations as code through open source? So, you know, we've done a lot of regulations as code thought, and we've done a lot of open source, but bringing those two together is one of the big focuses. And why would we want to do that? As with any financial firm-backed kind of thing, it's because it makes good business sense. And it makes good business sense because it reduces the effort. It's much more efficient if we can deliver understood code instead of having each bank interpret and design and implement the code behind a regulation. And then it's also less risky, which I hope to show you by opening it up and providing different pathways of communication and collaboration with regulations. So delivering regulations as code, you might think, well, doesn't that lock us in? Like, if a regulation is code, we all know that code, languages, technologies evolve every 2 or 3 years, et cetera. So if we were to deliver a regulation as code, doesn't that mean that we have now we've locked ourselves into a language that is going to be obsolete in a couple years? Or have we locked ourselves into an execution platform that's going to be obsolete? And how do we make this all future-proof? And that's really a key to open source regulations, is that it has to satisfy a whole wide range of all the systems and technologies and approaches that our different firms have for dealing with regulations. So we can't lock somebody into a particular technology or language. And so that's where Morpher, which is a FINOS open source project, comes in. And the whole goal of Morpher is to provide a data format for sharing business logic. And so, you know, business logic being the calculations, the rules, the aggregations, everything that is important about your application, not where it runs or what technology it runs on or what language you use to program it, but the actual business logic that is the key to the reason that your application exists. And so Morpher is that data format, and that's the key to it. So we can see how would that benefit us? Well, regulations happens to be a great use case for why that would be beneficial, because a regulation is a big piece of code that we want to share across different industries and different systems and different companies, and be able to adapt it into their systems and their data and make it work. And so a little bit about what we're going to cover. We're going to cover a particular regulation called the LCR, or the US Liquidity Coverage Ratio Regulation. The thing about the LCR is that it's nicely sized. This came out of the special interest group. You know, in discussing what we would use as a first case, the LCR was suggested because it's nicely sized. It's complex enough to be meaningful, but it's easily understood as well. And it's not competitive, which is a big key. So if we open source this, we're not giving away anybody's competitive advantage, and we can really understand what it means to collaborate in open source on a regulation. And so the key to the LCR is that what it does is it takes cash flows, all kinds of cash flows, into different groups, and it categorizes those into different groups or buckets, and then it applies a haircut to those based on the groups, and then it aggregates all that stuff up, and then from those aggregations it takes those results and applies some math on it to come up with a ratio, because the whole thing in the end is one number, it's a ratio. So we've got categorization and rules, we've got aggregation, and then we've got math all mixed in to one application. One key to, while we go through all this, one of the pillars of, or actually three of the pillars of Open Reg Tech are that, first of all, we need to get it correct. That is the primary thing that we want to do. We don't want to send out a bad regulation and have everybody do it wrong. With that effort to get correctness is where the collaboration comes in, right? And so all that collaborative effort leads into the correctness. And then with the collaboration comes agility, and it goes around in a circle in a big cycle. So we want this big cycle. This is what we're aiming for in this whole thing, in the whole effort. And this ugly slide, this is my ugliest slide of the presentation. This ugly slide is really to remind me to stop talking about what we're doing and actually start showing you with some real proof. So let's take a look at the regulation, the LCR. So this is one of the documents that defines the LCR. And you can see that it's actually a pretty nicely structured specification for an application. It starts out with some definitions of the business concepts that are used in here. And you can drill into here and see that it actually goes into, the data constraints that go along with these business concepts. So here we're saying that a currency is defined as any of the G7 ISO currencies. And then it's got some rules in there about, if it's not an ISO currency, what do? You convert it to USD, et cetera. So it's oops, didn't want to do that. But it's a nicely specified regulation. And some of, it's got other bits about, the rules and stuff. But the point here is that it's laid out fairly well in one document here. And if we go and check out the code actually looks a lot like the documentation here. And so everything that we just saw in those business concepts, sorry, scrolling back a bit, we find in those field definitions, we find right away in the code. And if we go and say, look at currency, we see that, there's the G7 precisely defined. And so where you saw all that text in the documentation, that actually translates down to this small bit of code, which is pretty convenient. One of the other things that the spec does is it gives us all the data sets that are required in order to run the thing, all the fields in the data set, so which is nice and convenient because, as you might have guessed, we can take that and convert that straight into code as well. So now we've defined the data set. So here we're looking at where we looked at this assets data set. We're looking at the code that defines that assets data set. And again, it matches exactly the specification. And here's the actual calculation, which is the definition of the LCR is high quality liquid asset amount divided by the total net cash outflows. And what this is really trying to do is make sure that you have enough coming in to be able to cover 30 days of going out if there was some kind of catastrophic situation. And as you can see, this is all a bunch of math. And it's just, so it defines, here's the HQLA amount, and then over here it defines, well, this is what the HQLA amount is. And then it keeps drilling down into pieces of this until it gets finally down to the bottom here, where it starts to get into the aggregation parts. And this is where we see that the regulation is trying to express something in English that is actually probably better expressed in a programming language. So right here, we're wondering, they're trying to translate what the concepts are, but if we go into the code, we can see, again, it matches the regulation pretty straightforwardly. So everything we saw in that structure, from the LCR to the HQLA definition to all those sub-pieces, all the way down to, we get to the aggregation. And so we can see in this code very clearly what the aggregation's doing, and it's I think, personally, it's a lot more clear than what they were trying to express in the English version. And so you might say at this point, well, I don't speak code, and I don't read code, so that's great for you, but it's not going to really help me or my users out, which is where we start leveraging the Morpher tools. So one of the things that Morpher provides in its tool set is a tool that allows you to interactively go in and look at business logic. So it's a bit like like a museum exhibit of regulation and taxation or something like that. If you wanted to, maybe if we had one of those in 100 years, this would be an interactive exhibit where you could go in and play with the LCR, and I'm sure your kids would love doing that, or I guess grandkids at this point. But what we can do is, so here's the LCR again. Now it's in a visualization form. And we start drilling into all these things. So the HQLA amount again, now we can go back and we can see, here's all the drill-ins to that. And we can drill in even further and see how these rules are done and drill in even further. And what we're doing actually is we're drilling from the math that defines the top through the aggregations and all the way into the categorizations. And that's an important note for anybody who's designed applications, because usually, I think it's pretty typical that an application like this would be divided into lots of pieces. So the categorization might be happening off in ETL in SQL code. The math might be in, I don't know, Scala or something like that. And then the aggregation might be again in SQL or in Spark or something like this. But what we're looking at here is the entire regulation. So if you can come into this tool, and understand the regulation through this interactive way, you can understand the entire LCR. And so we can see here what's going on is this is the bit that's actually applying the rules to a particular cash flow. And so it's saying that, look, if to get to an asset to be a part of the rule 20A1C, it needs to have particular values. So it needs to be, the product needs to be SD7 or SDC10, et cetera. So I mean, here's the flow chart of the rules. And so anybody who's developed an application like this has probably experienced the moment when we've released the application and we start immediately getting calls from the business about, well, I expected this particular asset to get assigned over here, but you've bucketed it over there. What's going on? And what usually happens in that case is that the dev teams go off for days, maybe, and come back with an answer. And what they're doing is they're trying to piece together all the little bits of code that's scattered out across the database, across the application. It's like a forensics exercise where they're trying to pull all these bits of code together and understand what's going on. And with this tool, then we're able to, instead of doing all that, we can just point them to this tool and say, hey, actually, you can go in and find out exactly why that happened, after the fact. So you can go in forensically with this tool and discover that, hey, this asset got categorized into that bucket because it matched these particular fields. And so that's pretty useful. And then, even further, we can go in and start playing with these values. So this is another part of the specification. It's a smaller example, but what this is doing is showing that with the Morpher tools, you can actually go in and see how things will, basically what-if scenarios, see how things will act. So in this case, we're applying this note 4 about how to calculate the return amount that we want to use in the aggregation by going in and actually playing with the data. So in this case, we see that, look, if we categorize the collateral class as G2Q, plug that in, now we see interactively that we're going to come up with this result. Actually, let's finish it off by actually plugging in some real numbers. and we see the actual result real time. And so if we go in again and say change it to now S1Q as specified, now we go, we follow the branch. And so all this is generated automatically with the Morpher tools from the business logic. So it's guaranteed to match what's in production. This is generated from the code that's actually executing as well. And so by deploying this, you're deploying live documentation that's interactive, that's guaranteed to be exactly what's happening in production as well. And further, we can now add test cases and use this in unit testing. So one of the ideas behind this whole approach is that you've got the business experts giving rules and interpreting the rules. And if we can, maybe sit with the business experts and code this up real quick, then give them this UI, then they can be sure that we are capturing the rules correctly, the way that they expect them to be. And once they've done that, they can play around with different data values, and then save those into test cases, and those become part of the unit test. And so through these tools, we've now added a whole bunch of unit tests to the liquidity coverage ratio regulation. Now, as we go into more of the regulation, it's interesting that this table here is actually specifying a set of business rules. And what they've basically gone and done is created their own little mini programming language in PDF format. So we're actually supposed to know that this star means that we want to select the maturity amount as the return result, and that this hash thing here means that we ignore this field. And so they've created their own little programming language, at which point you kind of think, well, we already have programming languages. Maybe we could use a programming language that exists, which obviously is what we're doing here. But an interesting thing in here is this little tidbit here. So what this is doing is categorizing a deposit into 32J14. So it's saying if we get a deposit that matches all these fields, then we want to categorize it into 32J14 until we get to this point that says, oh, by the way, if the collateral value is less than the maturity amount, subtract that from the maturity amount and then categorize that into 32H, which is like a twist that up until now nobody expected. But it does leave a question as to, so are we supposed to just return 32H with the maturity amount minus the collateral value, or should we return 32H plus 32JI with the difference so that we have two groupings? I don't actually know the answer, so I'm going to take a poll. Who thinks that we should just return 32H? Raise the hands. One person. Who thinks we should return both? Wow, 2 people, and everybody else is undecided, which is cool. It's cool to be undecided. Well, it turns out I made a guess, or we made a guess, and our guess was that we would just return the 1. And it also turns out that our business experts went in and created some test cases, and we failed the test case because actually we should be returning the 2. And so again, the interactive tools really sped up the process of being able to understand this. And so now let's go fix this. And I'm going to go in live into the code. And because I didn't know, I had actually written the rule, but all I need to do is undocument that. I'm going to kill the server, and then recompile and run the server again. And now we can take a look. Now it's returning the 2 values. And if we go into the test cases, we see that it passes. So we're all good. This is what it was supposed to be. So that highlights the interactive nature of it. But really, the reason I did this was because this is also what could be happening in open source. So imagine that this is an open source collaboration in a project hosted by FINOS, for example. And we're getting those suggestions of, maybe Bank X says, hey, you interpreted this wrong. Let me submit a PR. And, maybe even the regulators are involved and they're like, oh yes, that was unclear. This is what we meant. And then we can all collaborate on that. And so what happens with regulations is that there is a feedback loop between the regulators and those being regulated, but it's very slow. Like they give us the specs and we go off and think about them individually and then come back with a response. And then there's this whole back and forth and it's very official. But imagine an open source world where we were doing that all totally out in the open. So everything's clear, but a lot faster through PRs, through comments, and through suggestions and those kinds of things. And so that's basically an example of how that could be. We can make those changes and fixes extremely quickly, and it would be very clear for everybody what was meant by that regulation. All right, now I'm going to go back to not live stream. Back to the presentation. All right, so now the one thing I haven't really talked about is it's great that we've written this, it's great that we've collaborated on it. How are we going to execute it? Well, one of the ways we can execute it is by leveraging more of the FINOS ecosystem. And we have a presentation later today with Goldman and Legend, but basically what we've done here is that we've implemented an entire regulation in one application in Morpher. And what we can do is we've got those data sets that were defined. We know what the data sets are that we need to run this thing. So we can take that information and hand that off to Legend. And Legend can be used to procure that data set from our on-prem systems. And then we can take that and hand that off to Spark. And we can run that in something like the Databricks Lakehouse. And in that way, the regulation has been defined in open source. The execution environment is in a managed service. And all we need to do is plug in our on-prem numbers to this Lakehouse. And we can do that with Legend. And then the whole thing just runs. And so that's an interesting, that shows the value of pulling all these open source things. And the interesting thing is that that's all FINOS members, and it's all open source technology. And you might decide that's not how you want to run it. You might want to run it internally instead. And so here we highlight that with Morpher, it doesn't dictate either the way you write it or the way you run it. The whole goal with Morpher is that it's in the middle. It's the way you save that business logic and store it. It's not dictating that you need to run it in a particular way, and it's not dictating that you need to write it in a particular way. So we could actually take that big application and split it up for execution. We might say that, that categorization phase should happen in ETL, in SQL. And so we'll generate that out into SQL and let that run in the ETL part. And that aggregation phase should really happen in Spark, for example. And then that calculation phase, that's a natural fit for a regular programming language. So we can put all that math into Scala and then bind that all together. So we can do that because Morpher provides these tools to be able to write what we call backends, but backends are basically transpilers, or the documentation that I showed you before is a backend to write documentation. And we give tools to the users so that they can write their own backends. And so it's flexible in that manner. And then again, so Morpher's in the middle. And so right now, if you wanted to write an application, the language that I showed you before is another open source programming language called Elm. And that's one of the languages that we use. Another language which Capital One is working on is to be able to do the same thing in Scala, since that's a popular language. And then we've also worked with Microsoft and their Bosky team to be able to compile Bosky into Morpher. We had a presentation last year where we compiled Pure and Legend into Morpher. We did a code sprint this year with Regnosis for Rosetta. So Morpher is really aimed at general purpose. It's not just for regulations. It's really for general purpose business logic. And business logic is anywhere from trading systems to regulations. And so, we really aim to be that middle and allow tools to do what they do best on either the front or the back. We don't want to own execution, and we don't want to own a programming language or a particular development environment. We just want to be able to piece all those things together. And so that's where Morpher fits in, and that's what makes it agile. That's where the agility comes in. All right. I have to put a picture of myself in, and I figured I'd put it in the end because I was tired of putting it in the beginning. I was going to pepper it somewhere in the middle and just see what I would do with that, but I decided let me just do it at the end. I do have to highlight that the LCR was contributed to FINOS by Morgan Stanley. So it is a contribution to Morgan Stanley. It's open source now, but we contributed the majority of it. I have work at Morgan Stanley. And that's me looking thoughtfully into the future of regulation. I usually put a much more embarrassing picture of myself, but I figured maybe not this time. All right, and then the final bit is, one thing about the contribution from Morgan Stanley was that it's not complete. And we had the option of making it complete or leaving it incomplete, and we decided to leave it incomplete specifically so that we could see what it's like to do it in open source. So what would it be like to finish this off in the open source community? So expect to see some tech sprints announced that around the FINOS community come together to finish this thing off and make it complete. And we get some experience about what it means to have an open source regulation through that. And then here's all the links that you might be interested in to both look at Morpher and to look at the Open Reg Tech in the LCR. And with that, I think we're done. I have 2 minutes, 2 minutes for questions. Okay, great question. The question was whether real-time regulations were valuable versus these batch regulations. And yes, there are regulations that would benefit, and it's not just the regulations, it's the information, obviously, to the firms who need to know the results of those regulations, and they probably want to know that in real time in a lot of cases. And again, that highlights one of the advantages of getting that business logic into something like Morpher is that we can project it into a real-time system. So, using something like Kafka streams. Yeah. Oh, was it? Okay, perfect. I'm glad I fired the gun then. Yeah. But yeah, we can generate the Kafka streams logic, or there's not to hide. I mean, we actually talked to Hazelcast about Jet and being able to do the same thing with Jet. So there's a lot of options for being able to do that. But the key is that you're not risking rewriting your business logic just to make it real time. It's the same business logic and it's safe. You've already proven that it's correct. You're just projecting it onto a different execution environment. Oh, thank you. Yep. Cool. Excellent. Thank you. So for those who couldn't hear, it was just pure compliments. All right. Thank you.